Okay, so today we will talk about scale drawings and models. The good thing is that this is exactly set up just like we have in the past with the ratios and the proportion. Really, the only thing that we're changing here is we're looking at actual measurements. So we're kind of really applying it to the real world right now. Okay, so scale drawings and models. A scale drawing or model is used to represent an object that is too big or too small to be shown in its actual size. The dimensions of the objects on the scale drawing or model are proportional to the dimensions on the actual object. So once again, we're kind of looking at those measurements. Really, a lot of architects and stuff like that use that to build or to put a map of a, let's say for example, an amusement park. So they use these scale drawings or models to kind of help you look at the sizing of stuff to a little bit something smaller. Okay, so when we're looking at a scale, the scale is the ratio of the size of the model to its actual size. Okay, so the scale equals the model slash actual. Okay, so the scale once again is that smaller number that I'm going to get out of the ratio that I put equivalent to, and that model is going to be like the actual size. Okay, a scale can have the same units or different units, and you can use a scale to find a missing measure on the model or the actual objects. You're simply setting up and solving the proportion just like we have done in the past. Okay, so looking at example 1, it says the scale on a drawing for a new pool is 2 inches to 7 feet. If the length of the pool on the drawing is 10 inches, what is the actual length of the pool? Okay, so I did kind of read this instead of saying 2 inches equals 7 feet. I read it more as a ratio, so 2 inches to 7 feet. This is a ratio, okay? It's just letting me know that, hey, for every 2 inches, it's going to equal that 7 feet. So I'm going to go ahead and put that into a ratio. So I have 2 inches over the 7 feet. Now, what they want me to figure out is if I actually had 10 inches, what is the actual length of the pool? Okay, now if I look, 2 inches is the width and the 7 feet is the length. So I need to figure out what it is here. Now, when we set up the proportion, we want to make sure that we are looking at the consistency here. So if I have inches at the top and feet at the bottom for my first ratio, I want to make sure that I also have this exact same measurement on the same side. So if I look at the measurement that they gave me 10 inches. Because I put inches at the top, I also need to put inches at the top on my other ratio. So I have 10 inches at the top, and they want me to figure out the length of the pool. So I'm going to go ahead and put X at the bottom because I do not have that information. From here, all we do is cross multiply like we've done in the past. So first I have 2 times X. That gives me 2X equals, and now I have 7 times 10, which gives me 70. Okay, now from here, I just need to get X by itself. So just like we've done in the past, I divide by 2 on both sides, and X equals 35 feet because we are looking for the feet here. So once again, it's exactly the same thing. All we are doing here from the first to the second part is that we're simply just putting into proportions, making sure that we put our ratios correctly to solve for what measurement they're trying to have me find. So looking at the next one, it says the blueprint for a house uses the scale 1.5 inches equals 2 feet. If the living room is 18 feet long, find its length on the blueprint. Okay, so once again, that ratio that's given to me is 1.5 inches over the 2 feet. So now that I set my proportion up, I need to make sure that my next measurement that is given to me is in the right place according to how I set my first ratio up. So I do have inches at the top and feet at the bottom. And it says if the living room is 18 feet long, I need to figure out where to put that 18. Now it is in feet, so I need to make sure that I put the 18 feet at the bottom. At the top, we're trying to figure out the length still in inches, so we are going to go ahead and put that at the top. So once again, we're going to multiply like we usually do. So first I have the 1.5 times the 18. That is going to give me 27 equals, and then I have 2 times x. 2 times x gives me 2x. Now, I did write it differently because I did go in a different order this time. That's completely okay. Remember, your main focus to get x by itself, and you want to divide by the number next to that x. Right now, what I have next to the x is that 2, so I'm going to divide by 2 on both sides. 27 divided by 2 does give me 13.5, and we are looking at inches here. And 2 divided by 2 is just 1, which is the same thing as just x. So I have 13.5 inches x. Okay, and let's go ahead and do one more. So let's look at number 4. Or actually, number 4. Actually, let's look at number 3, sorry. So a model of a car uses a scale of 2 1/4 inches equal to the 3 feet. If the model is 14 inches long, what is the actual length of the car? So remember last time we had fractions, I did say make sure you convert them into decimals when we're setting up those proportions, especially because we're multiplying. So the ratio that's given to me here is 2 1/4 inches to that 3 feet. Now I do have that fraction, which is a 1/4, and 1/4 is equivalent to 0.25. So when I set that up, I have the 2.25 over the 3 feet. Okay, now this time I'm not going to put the labels just so that you guys know you don't have to include those labels every time. But if it helps you figure out and to stay consistent for my next ratio, I would go ahead and put them. So the next part says, if the model is 14 inches long, what is the actual length of the car? So I have 14 inches. I got to remember, hey, did I put 14 at the top or at the bottom for my first ratio? Now I do have 2.5 inches, which is at 2 1/4 inches. So I did put inches at the top. So that means that the 14 does have to go at the top of my ratio for the second one. Now at the bottom, since we're trying to figure out what it is to the actual size in feet, I am going to put x. And then we cross multiply. So I have 2.25 times the x, that gives me 2.25x is equal to, and then I have 3 times 14, which gives me 42. From here, all I have to do is just divide. So I divide by the number next to the variable, which is the x right here, because I want to get that by itself. 2.25 divided by 2.25 is just 1, which is the same thing as x. And then I have 42 divided by 2.25, and that is 18.6 feet. Although, yes, it is a repeating decimal, I'm going to go ahead and round to the nearest tenths and put 18.7 feet. Okay, let's move on to the bottom here. So all of these are all going to be exactly the same. Once again, I would recommend you guys for any of these fraction ones to make sure you convert them into actual decimals. And you can convert them into actual decimals by just plugging them into your calculator and it'll give it to you in a decimal, okay? Moving on to finding the scale though. When we're actually finding the scale, what we're trying to do here is they're giving us the actual measurements in the drawing, but what we need to do here is find the smaller version of that number. Okay, so first it says to find the scale of a drawing or model. First step, you're going to want to write the ratio of the model length and then to the actual size, and then you're going to simplify the ratio to the numerator is 1. So basically what we're really doing here is we're finding the constant rate of change of this, if you kind of want to think about it that way, okay? So if I look at this, I do have the drawing length is 9 inches and the actual length is 45. So what I'm going to do here is I'm going to put 9 over the 45, okay? So once again, we want to make sure that the numerator is to a 1 because that is the drawing length. So it means that 1 inch is equivalent to the actual size of whatever the feet is. So in order for us to simplify this, once again, I'm going to go ahead and figure out, hey, do I have a common factor that I can divide both 9 and 45? If I look at 9, my factors for 9 are 1, 3, and 9. Okay. For 45, I have a few. So I have I have 1 times 45 gives me the 45. I also have 5 times 9 gives me 45. And right off the bat right here, we have 2 9s, so they both share the factor of 9. So I'm going to go ahead and divide by 9, both the top and the bottom. 9 divided by 9 gives me 1, and 45 divided by 9 gives me 5. Okay, now to put it into the actual scale, I'm going to go ahead and represent it as a ratio, which is equal to each other. So I'm going to have 1, and the 1 represents inches, because at the top we did put the inches, so I put 1 inch is equal to, at the bottom we did put feet, which is at 45, so I put 5 feet, because this is equivalent to that. Okay, let's do another one. So for number 12, I do have a fraction here once again. All we have to do here is just plug it into our calculator. And honestly, for these to simplify, you can also go ahead and put it in a calculator, like just 9 over 45, and it will give you the simplified version of it as well. Okay, so if I have 6 2/5, I'm going to go ahead and make that into a decimal, and that is equivalent to 6.4 over, and my actual size is 120. Okay, now we can go through the process of actually putting this in the calculator or not. This one you might have a little bit of trouble, just because I don't believe the calculator will simplify a fraction with a decimal in it. But remember, if my goal is to get the numerator to 1, all I really have to do here is just divide by the actual numerator. Okay, so always divide by the numerator. In this one, I have 6.4 as my numerator, so I'm going to divide both the top and the bottom by 6.4. Okay, same thing I did over here. I divided, the 9 was my numerator, so I divided both the top and the bottom by 9. Okay, 6.4 divided by 6.4 is just 1 over, and then 120 divided by 6.4 is 18.75. So now putting it in my ratio, the top number is represented by meters. So I'm going to go ahead and put 1 meter is equivalent or equal to, my second number is kilometers. So I put 18.75 kilometers. Okay. All right. And let's see. Let's just do one more just in case. So looking at the number 13, says 2 cities are 750 miles apart. If they are 8 inches apart on a map, find the scale. Okay. So once again, I do have this ratio, and they don't actually give it to you in the formatting that you would know what goes at the top and the bottom. I would go ahead and always put the scale of it, the smaller number at the top and then the bigger number at the bottom. So here I have 8 inches at the top and the smaller number, 750, which is the bigger number at the bottom. Okay. Now, in order for me to get the numerator to 1, once again, you want to make sure that you are dividing by the numerator, because if I divide by the numerator, it's automatically going to give me 1. So I divide by 8, both on the top and the bottom. 8 divided by 8 gives you 1 over, and then 750 divided by 8 is going to be 93.75. From here, I just once again put it in a ratio. I did have inches at the top and miles at the bottom. So when I put this in my ratio, I have 1 inch is equal to the 93.75 miles.